Audio Jungle. Audio Jungle.
Hello everyone. So now for today's session, we have to talk about the momentum conservation. We have to write momentum equation. Okay. So coming to the momentum conservation. So what is the momentum conservation? It is simple. Rate of change of momentum will give the force, which is nothing but Newton second law. And if it is momentum conservation, so definitely that if you talk about the momentum equation, so that momentum equation is what? Based on momentum conservation. That momentum equation, if you talk about the momentum equation here, momentum equation is what? Based on momentum conservation. So how to write momentum equation? It's a Newton's second law. What is the Newton's second law? It is rate of change of momentum. What is the momentum? First of all, momentum is nothing but, suppose this is the one body, okay, this body mass is nothing but m, and it is moving with velocity v. Momentum is nothing but mass into velocity. It is denoted by small p, mass into velocity. So rate of change of momentum, if I say rate of change of momentum, then it means what? Rate of change of momentum, rate means per unit time. So if you write this, what I can write? Mass is what? Conserve. Mass I can take outside. D by d. Rate of change of velocity is what? Mass into acceleration. Yes or no? What is the mass into acceleration? Is nothing but force. This is what? Newton's second law. Yes or no? So finally we got momentum equation, which is nothing but force is equal to mass into acceleration. Right? This analysis, whole analysis, I hope you understood. So now this is what? Mass into acceleration. This also you can write in one more format. Mass into acceleration is what? Velocity by time. Yes, you can write dv by dt, or initially if you take it is 0, at t is equal to 0, velocity will be 0. Okay, so dv by dt you can write v by t. This you can write mass by t into, this mass by t you can write m dot into, what is m dot? It is mass flow rate. What will be the unit? Kg per second, that you know. Okay, So finally you got force is equal to mass m dot into v. What is this? This is the velocity vector v, you can say. Okay. Now why I am explaining this m dot? Because this is related to the continuity equation, mass conservation. Okay, fine. Now what about this force? So this force will be the external force. Okay. Why there is the fluid flow? Because of this force only. Okay. What are the different forces? You can say we have a gravity force. Yes or no? Gravity force, you can say it is denoted by Fg. Okay. Then next we have next force, major force we have pressure force. Third we have viscous force. What is the fourth? It is turbulent flow, turbulent force. Okay. Then we have compressibility force. Then we have minor force like surface tension. Electromagnetic force, etc. Okay. So these are the forces responsible for the flow. If there is the flow, so this type of force definitely will come into picture due to reason behind reason behind okay fluid flow. These are the reason. Maybe fluid flow is what because flowing because of the gravity force. Maybe there is a fluid flowing because of the pressure force or viscous force or because of turbulent force, compressibility force, surface tension, or you can say if there is a fluid flowing, so these type of forces will be existing there. Understood? So these are the major forces, basically like gravity force, pressure force, viscous force. Yes or no? Like shear flow and all, it is because of the viscous force only. You all know that. Huh? So you can write here pressure force Fp, viscous force Fp, turbulent force Ft, compressibility force Fc, and this is what F minor. So I can write here minor. Yes or no? Now, so these are the forces what I have shown you. If there is a fluid flowing, so definitely this type of forces will be existing there. Based on this different type of forces, we have different type of the equation related to fluid flow. Remember, whatever I am talking here, it is the dynamic fluid. Okay, I mean fluid is not a stationary condition; it is in motion condition. Fluid in motion. Okay, I can write here if fluid is what in motion. No, if fluid is what in motion, fluid in motion, then this type of forces will exist. All right. Now, so be careful. Like as I told you, this type of forces will be existing. Based on this, we have a different type of equation. What are the equation? Okay. Now, see, suppose I'm taking all the forces here. Okay. Just give me time. Okay. Let me write the forces here so it will be clear. It's very easy and very simple. Nothing to worry. Okay. So total number of forces I told you: gravity force, pressure force, viscous force, turbulent force, compressibility force, and minor forces. So now I can write all the forces in one box. So what are the forces? Gravity force, pressure force, viscous force, turbulent force, compressibility force, and minor force. Okay. Then this equation will be called, they all the forces will constitute one equation. This equation will be called as Newton's equation of fluid flow. Okay. Now you have taken compressibility force and minor force outside. This compressibility force and minor force. This is what minor. So minor force you have taken outside. Now how many forces are left? Gravity force, pressure force, viscous force, and turbulent force. Then these forces will be constituting one more equation called Reynolds equation of fluid flow. Now one more force you can take outside, turbulent force. If you take turbulent force outside, so how many forces are left? Called gravity force, pressure force, and viscous force. These three forces will be constituting that equation which is called Navier-Stokes equation. What it is called? Navier-Stokes equation of fluid flow, which is also comes to momentum equation. Okay. All right. Now if you take one more force outside, which is called viscous force. Okay. So this box again I will draw in the next slide. So now you have number of forces here. Okay. So here you may have right. So here I can show you. If you take one more force which is called FP, so total number of forces are available here: gravity force, pressure force, and FP force. FP on this side. Now if you have FG and FP, if you take compressible flow this side, okay, so still you have Fg and Fp, right? Two types of flow here: compressible and incompressible. So if you have separated compressible flow, so what flow you may have? Only incompressible flow. So this is called, what it is called, Navier-Stokes, right? This is called Navier-Stokes equation or momentum equation of fluid flow. Okay. Now, if you are taken viscous force outside, so this equation called Euler's equation of fluid flow, and that flow is what compressible and incompressible both are there. Okay, previously what all the condition you have taken, both type of flow were available, compressible or incompressible. Now compressible flow you have separated, so this will be here. This will be called as Bernoulli equation of fluid flow. All right. So hope you now you can separate force wise that type of the equation based on the forces. Now you can separately understand this. Okay, easily you can understand. Fine. Now our job to write the momentum equation. So for the momentum equation, how many forces are there? Take three forces. So if I will write momentum equation here, so how many forces will be there? Three forces. How many forces are there? Three forces: gravity force, pressure force, and viscous force. Gravity force also called as body force. Okay, pressure force also called surface force, and this is the viscous force. This also comes under body force. All right, fine. Now, so we can write first that pressure force one by one will write. Okay, take body force means gravity force. Okay, which is called body force. What is the gravity force? Weight of the body, weight of fluid. Here you can write. What is the weight of fluid? W. It is mass into gravitational acceleration. Or you can write density is mass per unit volume. So what is the mass? Density into volume into gravitational acceleration. But for the element, if you check, this element I have taken from the flow field. This is the flow field, and this small element I have taken. Okay. So for this, volume is dB, and for the whole system, volume is V. So for elemental, I am writing. So what will be the body force or gravity force? I can say density, gravitational acceleration, it is vector quantity, gravitational acceleration, and a small volume for the elemental, it is dB. Yes or no? This is the body force acting on the full volume of the system. So you have to take triple integration because this is the volume. Okay, so triple integration you have to write like this. Close. Let me show properly. Hope you understood why it is triple integration, because volume is there, and obviously body force will be acting throughout the volume of the system. Okay, so whole volume you have to take. Why it is closed circle? Because for the closed system you are taking. All right. Now similarly, pressure force you can write. What is the pressure force? Fp. What is the pressure force? Pressure into area. What area? Obviously surface area. So I can take this small surface area here. And I can say this elemental surface area is ds. So it is acting on surface, so surface area will come. So surface area means double integration. It is pressure force is what? By nature it is compressive. So I can write here negative sign because it is compressive force. Pressure force is basically by nature it is compressive force, hence negative sign you have to take. Okay. Third one, viscous force. Okay. So basically viscous force we have that we can write only Fp. We are not going to open it. Fp is sufficient for this. Whenever it is required, we will open that. Otherwise, because viscous force, if we write the equation, it is very lengthy. Again, one more to 2-3 slides required to open and to write final equation. Better we'll keep it as it is, like f we will write, so that will be okay. Okay, now so all the forces for the Newton's for the momentum equation, all the forces means Fg, gravity force, pressure force and viscous force, which is nothing but triple integration rho v into dv minus double integration p into ds plus viscous force here. Okay, this is the one thing. Second thing, like m is nothing but mass flow rate, okay, into velocity. Check here, here, mass flow rate into velocity. Okay, so what is the mass flow rate? That comes from the continuity equation, mass conservation. What was the continuity equation, if you remember? The continuity equation was right here. So this is the continuity equation. Mass conservation. Remember, this momentum equation we are writing with the help of continuity equation. Same thing, energy equation will be writing with the help of momentum equation. Okay. So this is nothing but F. What is the continuity equation? It was dou by dou t triple integration rho dv plus double integration rho v vector into ds. Okay, this was the mass m dot, and now we have velocity. This is the velocity vector, so we'll multiply by the velocity, so dot. Now this f, right and left, we can equate. Yes or no? We can equate this. What we'll get? So we'll write this combined and we'll write this. So if we equate this both sides, so we'll have equation. It will be dou by dou t triple integration rho dv, rho v vector dv plus this is what volume, this is what surface integral rho velocity vector, already it was there, and then again velocity vector will be multiplied. Now here check this, I am saying this velocity will be multiplying inside the bracket, so is equal to that force was gravity force, body force or gravity force, so it was rho dv into g or rho g dv plus minus pressure force, okay, minus pressure force p into ds plus viscous. This is what momentum equation. Done. Hope you all understood this. So this is the momentum equation in differential form. Momentum equation in integral form. In integral form. All right, momentum equation in integral form. Done. Now we can write this momentum equation in vector form also. Okay, we can write this momentum equation in vector form as well as in differential form also. So first let me write that vector form. So now I will not take more time. So from the integral form directly I will write vector form. So here I can give the heading because it will again open each and every step, so it will take more time. So better I will write directly. Momentum equation in vector form. Take the integral form and from there you can write this. What you can write? Dou by dou t rho v vector plus rho v vector is equal to rho g minus grad t plus viscous force. So this is the vector form, or if you check this also, I mean I can write one more step so it will be more clear to you. I can take density outside. So this is what rho okay. This is what? This is the local acceleration if you are getting me. This is called local acceleration. And this is called convective acceleration. Okay, you can write and combine this local and convective acceleration. So you may get the total acceleration. Okay, or sometimes it is called material acceleration, substantial acceleration. Okay, so this will be rho d v vector. This is the total acceleration. Okay, or material acceleration or substantial acceleration. This is the final, I mean, easiest form of the momentum equation, shortest form you can say. Okay, grad T plus mu square, not mu square, it's mu grad square. Grad square v vector. Okay, so this is the final momentum equation in vector form. I told you this viscous force, it is very lengthy to open, but directly I have written here. Okay, directly I have written here this. So what is the momentum equation? Final. in vector form. You can write this and always remember, okay, it will be very useful to you. Is rho total derivative or substantial derivative, okay, fine. You need to remember, okay, somewhere if it is asked to you, so you have to answer. Fine. All right. This was the momentum equation in vector form. Now we'll write differential form. Okay. We have to write the differential form of the momentum equation next. Momentum equation in differential form. Okay. So that differential form you can write in three different axes. Okay. Directly I'm going to write, which is called Navier-Stokes equation also. Okay. What it is called? It is called momentum equation in different differential form. That is also called Navier-Stokes equation. This momentum equation in differential form will be also called as Navier-Stokes equation. Okay. And how many forces are here? For this, only three. That is gravity force, pressure force, and viscous force. If you check here also, see, this is what gravity force. This is what pressure force, and this is what viscous force. So now, if you write this, x direction, y direction, and z direction, we will write now. It is nothing but dou by dou t, rho u, small u, okay, plus grad. This is the differential form in x direction. All right. On in this is the dou p by dx plus rho gx. Gx means gravity in x direction only because you are writing equation in x direction. And this is the viscous force in x direction. Similarly, the same equation you can write in y direction. So instead of u, we will have small v dot rho. Instead of u, we will have a small v. This is capital V vector. Instead of x, because it is in y direction, so dou p by dy, rho g, it is y, and it is this. Okay. Similarly, this is what dou by 2 rho w. Instead of uv, we have w v vector x y z, this is what z now, plus this is the viscous force. Okay, so momentum equation in differential form you have seen in all three direction, x direction, y direction, z direction. Again, viscous force, if you want to write, you can write in that open format. Here I have written, check this one last. No? Okay, because if you can understand easily what is grad p, if I want to open, what is the grad p? Grad p is nothing but pressure gradient. You can write I dou by dou x, j dou by dou y, k dou y, dou z, and here it is nothing but what p. If I say x direction, so x direction means what? It is dou p by dou f, because it is minus, so minus you have to take. If I say y direction, so what you have to take? Dou p by, check here in next step, dou p by dou x, dou p by dou y, dou p by dou. Similarly here, see, this is what rho g. In x direction rho g x, in y direction rho g y, in z direction rho g z. Check rho g x, rho g y, rho g z. Yes or no? So I hope you all understood momentum equation. Okay. So keep doing hard work. Thank you all. Thank you so much.